Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P4, Variant 3, May-June 2020. Let's get started. The sign shows the fees charged at a campsite. Today, there are 54 tents and 18 caravans on the site. Calculate the fees charged today. The total fees will be the cost charged for a tent, which is $15, times the number of tents that were on site, which is 54, plus the cost charged for a caravan, which is $25, times the number of caravans that were on site, which is 18. When we type this into the calculator, we get $1,260. In September, the total income at the campsite was $37,054. This was a decrease of 4.5% on the total income in August. Calculate the total income in August. If we represent the total income in August with Y, we have 100 minus 4.5% of Y equals $37,054. When we simplify the equation and make Y the subject, we get $38,800. The visitors to the campsite today are in the ratio men is to women equals 5:4 and women is to children equals 3:7. Calculate the ratio men is to women is to children in its simplest form. In order to get a final equivalent for these two ratios, we need to get the ratio share for the women to be the same in the top and bottom ratio. And we can easily achieve this by multiplying through the top ratio by 3 and multiplying through the bottom ratio by 4. This gives us 15:12:28. Today, there are 224 children at the campsite. Calculate the total number of men and women. First, we need to set up our ratio. We want to find the total number of men and women. So from the ratio, we get our equation as the total number of men and women equals the ratio share for the men and women, which is 15 plus 12, divided by the ratio share for the children, which is 28, times the number of children at the campsite, which is 224. When we type this into the calculator, we get 216. The space allowed for each tent is a rectangle measuring 8 meters by 6 meters, each correct to the nearest meter. Calculate the upper bound for the area of the space allowed for each tent. The area for the tent, which is in the shape of a rectangle, is length times width. To get the upper bound of the area, we need the upper bound of the length of the tent times the upper bound of the width of the tent. To get the upper bound of the tent's length, we add 1 meter divided by 2 to 8 meters. And for the upper bound of the tent's width, we add 1 meter divided by 2 to 6 meters. This gives us the upper bound of the area as 55.25 meters squared. The value of the campsite has increased exponentially by 1.5% every year since it opened 30 years ago. Calculate the value of the campsite now as a percentage of its value 30 years ago. Since the value of the campsite increases exponentially by a certain amount each year, then it means we are dealing with a compound interest scenario in this case. The percentage we are required to calculate will be equal to the current or the final value of the campsite divided by its initial value times 100%. If we represent the initial value of the campsite with small a, then based based on the compound interest formula, its value after 30 years will be its initial value, which is small a times 1 plus r over 100 raised to the power t, where r has been given as 1.5 and t has been given as 30. We've not been given the value of small a, but it doesn't matter in this case because they cancel out. So now when we type 1 plus 1.5 over 100 raised to the power 30 times 100% on the calculator, we get 156%. Draw the image of triangle A after a reflection in the line y is equal to negative x. So first, we draw the line of reflection, which is y equals negative x. Then from here, we need to reflect the vertices of triangle A in the line y is equal to negative x. So for point B on the triangle, since we move 3 units to the left to touch the line of reflection, we need to move 3 units downwards to pin the new position of point B. We need to repeat the same process for points A and T on the triangle as well. When we are done, we are able to map out the reflected image of triangle A. Draw the image of triangle A after a translation by the vector -2, -9. The translation vector dictates that we move each of the vertices of triangle A 2 units to the left and 9 units downwards. On the diagram, the movement for point C has been shown. After repeating the same process for points A and B as well, we are able to map out the translated image of triangle A. Describe fully the single transformation that maps triangle A onto triangle B. When we look at triangle A and its image, triangle B, we can tell straight away that this is an enlargement by a scale factor of half. Now all we need to do is find the center of enlargement. We can do this by connecting at least 2 corresponding points on triangles A and B. When we do this, we get the center of enlargement as -7, 8. And so the full description for the transformation will be enlargement by a scale factor of half about the center, -7, 8. Describe fully the single transformation that maps triangle A onto triangle C. When we look at triangles A and C, we can tell straight away that this is a rotation 90 degrees in the clockwise direction. So now we need to identify the center of rotation. For a 90 degrees rotation, the way to determine the center of rotation is this. Draw a line to connect at least 2 corresponding points on both triangles A and C. Then we need to draw the perpendicular bisectors of these lines. The intersection point of the bisectors is the center of rotation, and in this case, that is the origin. And so the full description for this transformation will be rotation 90 degrees clockwise about the origin. Here is some information about the masses of potatoes in a sack. On the grid below, draw a box and whisker plot to show this information. To draw a box and whisker plot, we need 5 different values: the smallest or minimum value, the lower quartile, median, upper quartile, and the largest or maximum value. From the question, we've been given the highest potato mass as 174 grams. We were also given the range as 69 grams. From this value of the range, we can calculate the smallest potato mass, which gives us 105 grams. We've been given the median value, which is 148 grams. We've also been given the lower quartile as 121 grams. Then finally, we were given the interquartile range. From this value, we can easily calculate the upper quartile, which is what we need for the box and whisker plot. This gives us 159 grams. The table shows the marks scored by some students in a test. Calculate the mean mark. The mean mark is equal to sigma f of x, which is the total sum of all the marks divided by the total number of marks. For sigma f of x, we have 5 times 8 plus 6 times 2 plus 7 times 12 plus 8 times 2 plus 9 times 0 plus 10 times 1. And for sigma f, we have 8 plus 2 plus 12 plus 2 plus 0 plus 1. When we type this into the calculator, we get the mean as 6.48. Solve the inequality. 3m plus 12 is less than and equal to 8m minus 5. First, let's group like terms. This gives us 12 plus 5 is less than and equal to 8m minus 3m. 12 plus 5 is 17. And 8m minus 3m is 5m. When we divide both sides of the inequality by 5, this is what we get. 17 over 5 in decimal is 3.4. So we have 3.4 is less than and equal to m, which is the same as saying m is greater than and equal to 3.4. Solve the equation. 2x plus 5 divided by 3 minus x equals 14 over 15. We can go ahead and cross multiply. This gives us 15 times 2x plus 5 equals 14 times 3 minus x. When we expand the brackets, 15 times 2x is 30x and 15 times 5 is 75. 14 times 3 is 42 and 14 times negative x is negative 14x. When we group like terms, we get 44x equals negative 33. And when we divide both sides of the equation by 44, we get x equals negative 0.75. Solve the simultaneous equations. You must show all your working. First, let's label the given equations as equation 1 and equation 2. From equation 1, we have y equals 4 minus x. When we substitute y equals 4 minus x into equation 2, this is what we get. To expand the square brackets, we square 4, which gives us 16. Then we multiply the elements in the bracket 4 and negative x, giving us negative 4x. Then we multiply this by 2 to get negative 8x. Then we square negative x all squared, which gives us positive x squared. When we expand the brackets, 2 times 16 is 32. 2 times negative 8x is negative 16x. And 2 times x squared is 2x squared. From here, all we need to do is move all the terms to one side of the equation and group like terms. This gives us 3x squared minus 16x minus 35 equals 0. We have a quadratic equation, so we can solve for x by applying the quadratic formula. When we do that, this is what we get. When we type the values under the square root into the calculator, we get 676. So for the first value of x, we have 16 plus square root of 676 divided by 6, which is 7. And for the second value of x, we have 16 minus square root of 676 divided by 6, which is negative 5 over 3. We can find the corresponding y values for these x values by placing their values into either equation 1 or equation 2. Let's pick equation 1. When x is 7, y is 4 minus 7. 4 minus 7 is negative 3. When x is negative 5 over 3, y is 4 minus negative 5 over 3, which is 17 over 3. All the lengths in this question are in centimeters. The diagram shows a shape ABCDEF made from two rectangles. The total area of the shape is 342 centimeters squared. Show that x squared plus x minus 72 equals 0. On the diagram, we have split the shape into two rectangles, A1 and A2. And so the total area of the shape will be A1 plus A2. For rectangle A1, its length is x plus 1. We can get its width by subtracting x plus 3 from 2x. This gives us x minus 3. And so the area A1 will be x plus 1 times x minus 3. For rectangle A2, its length is 4x minus 5 and its width is x plus 3. And so the area A2 will be 4x minus 5 times x plus 3. From here, all we need to do is rearrange the equation to be in the form stated in the question. When we expand x plus 1 times x minus 3, we get x squared minus 2x minus 3. And when we expand 4x minus 5 times x plus 3, we get 4x squared plus 7x minus 15. When we group like terms, x squared plus 4x squared is 5x squared. Negative 2x plus 7x is 5x. Negative 3 plus negative 15 is negative 18. So now we move 342 to the other side of the equation. Since it's adding, it goes to subtract on the other side of the equation. So negative 18 minus 342 gives us negative 360. And we are left with 0 on one side of the equation. So now we divide through the equation by 5. And this leaves us with x squared plus x minus 72 equals 0. Solve by factorization. X squared plus x minus 72 equals 0. So first, we rewrite x as 9x minus 8x. Notice that we picked 9x minus 8x because the product of 9 and negative 8, which is negative 72, is the same as the product of the coefficient of the x squared term, which is 1, and the constant term, which is negative 72. For the first two terms, when we factor out x, we are left with x plus 9. And for the final two terms, when we factor out negative 8, we are left with x plus 9. We can rewrite this as x plus 9 times x minus 8. When we equate x plus 9 to 0, we get x equals negative 9. And when we equate x minus 8 to 0, we get x equals 8. Work out the perimeter of the shape ABCDEF. The perimeter is the distance round the shape of an object. So in this case, the perimeter is equal to AF plus FE plus ED plus DC plus BC plus BA. AF is x plus 1, FE is x minus 3, ED is 3x minus 6, DC is x plus 3, BC is 4x minus 5, and BA is 2x. When we simplify this expression by grouping like terms, we get 12x minus 10. In the previous question, we found the possible values for x. The value for x cannot be negative in this case, so we go with x equals 8. When we substitute x equals 8 into 12x minus 10, we get 86. Calculate angle DBC. We can find angle DBC by applying SOHCAHTOA. This gives us tan of angle DBC equals the opposite, which is 11, divided by the adjacent, which is 27. When we make angle DBC the subject, we have tan inverse of 11 over 27. When we type this into the calculator, we get 22.2 degrees, correct to one decimal place. The diagram shows triangle ABC with point G inside. CB is 11 centimeters, CG is 5.3 centimeters, and BG is 6.9 centimeters. Angle CAB is 42 degrees and angle ACG is 54 degrees. Calculate the value of x. We've been given the lengths of all the sides of triangle BCG, so we can easily find angle x by applying the cosine rule. This gives us 6.9 squared equals 5.3 squared plus 11 squared minus 2 times 5.3 times 11 times cosine of x. When we make x the subject of the equation, this is what we get. And when we type this into the calculator, we get x equals 29.5 degrees correct to 1 decimal place. Calculate AC. To find the length of AC, we can apply the sine rule. This gives us AC divided by sine of angle ABC equals 11 centimeters divided by sine 42 degrees. We get angle ABC by subtracting the sum of 42 degrees, 54 degrees, and 29.5 degrees from 180 degrees. This gives us 54.5 degrees. When we substitute the value of angle ABC into the equation and make AC the subject, we get 11 over sine 42 degrees times sine 54.5 degrees. When we type this into the calculator, we get 13.4 centimeters, correct to 3 significant figures. Water flows at a speed of 20 centimeters per second along a rectangular channel into a lake. The width of the channel is 15 centimeters. The depth of the water is 2.5 centimeters. Calculate the amount of water that flows from the channel into the lake in 1 hour. Give your answer in liters. To find the total volume of water that flows through the channel, that will be equal to the volume rate, which in this case is the volume of water going into the lake every second times the total time duration. We've been given the time duration as 1 hour, so let's find the volume rate. The volume rate of the water is equal to the cross-sectional area of the water, which is fixed and is in the shape of a rectangle, times the linear rate, which has been given as 20 centimeters per second. The cross-sectional area is 15 times 2.5 centimeters squared. When we type this into the calculator, we get 750 centimeters cubed per second. Now that we have the volume rate, the total volume that goes into the lake is equal to 750 centimeters cubed per second times 1 hour. To convert centimeter cubed to meter cubed, we multiply by 10 raised to the power -2 all cubed. Then we convert 1 hour to seconds, which is 3,600 seconds. When we type this into the calculator, we get 2.7 meter cubed. To convert 2.7 meter cubed to liters, we multiply by 1,000, giving us 2,700 liters. On any Saturday, the probability that Aaron plays football is 3/4. On any Saturday, the probability that Bob plays football is 2/5. Complete the tree diagram. We've been given the probability that Aaron plays football as 3/4. The sum of probabilities at any branch must be equal to 1. And so to get the probability that Aaron does not play football, we subtract 3/4 from 1, which gives us 1/4. We've been given the probability that Bob plays football as 2/5. And so to get the probability that Bob does not play, we subtract 2/5 from 1, which gives us 3/5. Calculate the probability that one Saturday, Aaron and Bob both play football. The probability that Aaron plays football is 3/4, and the probability that Bob also plays football is 2/5. When we type this into the calculator, we get 3/10. Calculate the probability that one Saturday either Aaron plays football or Bob plays football, but not both. For this probability, there are two possible scenarios. In the first scenario, Aaron plays football and Bob does not play football. Or Aaron does not play football and Bob plays football. When we type this into the calculator, we get 11/20. Calculate the probability that Bob plays football for 2 of the next 3 Saturdays. So for this probability, we have Bob plays football on the first Saturday and he plays football on the second Saturday and does not play football on the third Saturday. This order of events will be PPX. There are 2 other possible orders which are PXP and XPP, making a total of 3. That's why we multiplied this probability by 3. The probability that he plays football on the first Saturday is 2 over 5, and the probability that he plays football on the second Saturday is also 2 over 5, and the probability that he does not play football on the third Saturday is 3 over 5. When we type this into the calculator, we get 36 over 125. When Aaron plays football, the probability that he scores the winning goal is 1 over 7. Calculate the probability that Aaron scores the winning goal one Saturday. The probability that Aaron scores a winning goal on any Saturday is equal to the probability that he plays football and scores a winning goal. The probability that he plays football on a Saturday is 3 over 4, and the probability that he scores a winning goal is 1 over 7. When we type this into the calculator, we get 3 over 28. The interior angle of a regular polygon with n sides is 150 degrees. Calculate the value of n. Here is the formula for finding the size of an interior angle in a regular polygon. In this case, we've been given the size of the interior angle as 150 degrees and we are asked to find the value of n. So we have 150 equals 180 times n minus 2 divided by n. When we multiply both sides by n, this is what we get. When we expand the brackets, 180 times n is 180n, and 180 times negative 2 is negative 360. When we group like terms, we get 30n equals 360. And when we divide both sides by 30, we get n equals 12. K, L, and M are points on the circle. KS is a tangent to the circle at K. KM is a diameter and triangle KLM is isosceles. Find the value of Z. The angle formed by a radius and a tangent is 90 degrees. The angle subtended by a diameter at the circumference of a circle is also 90 degrees. Based on the alternate segment theorem, if we know this angle as Z degrees, then this angle here is also Z degrees. Base angles in an isosceles triangle are equal. So now that we know this angle is Z degrees, then this angle is also Z degrees. Based on the fact that these two Z angles add up to 90 degrees, we can say 2Z equals 90 degrees. Or we can also look at triangle KLM and say that since we know that one of the angles is 90 degrees, then the sum of the Z angles must also be equal to 90 degrees. When we divide both sides of the equation by 2, we get Z equals 45 degrees. AT is a tangent to the circle at A. Find the value of x. Based on the alternate segment theorem, if this angle here is 58 degrees, then this angle here is also 58 degrees. We know two angles in this triangle, so to get the third angle, we subtract the sum of 58 degrees and 27 degrees from 180 degrees. This gives us 95 degrees. Angles on a straight line add up to 180 degrees, and so x plus 95 degrees must add up to 180 degrees. When we subtract 90 from both sides, we get x equals 85 degrees. F, G, H and J are points on the circle. EFG is a straight line parallel to JH. Find the value of y. These two angles are alternate angles, and alternate angles are equal. And so if one angle is 108 degrees, then the other should also be 108 degrees. Opposite angles in a cyclic quadrilateral add up to 180 degrees. So y plus 108 degrees should equal 180 degrees. When we subtract 108 from both sides, we get y equals 72 degrees. A, B, C, and D are points on the circle center O. M is the midpoint of AB and N is the midpoint of CD. OM equals ON. Explain given reasons why triangle OAB is congruent to triangle OCD. First, we know that OA, OB, OC, and OD are all equal because they are radii of the circle. In the question, we've been told that ON equals OM. If ON equals OM, then it means AB is equal to CD because they are equidistant chords. Now that we've shown that triangles OAB and OCD have their corresponding side lengths to be equal, we can conclude that based on the SSS criteria, they are congruent. The equation of line L is 3x minus 8y plus 20 equals 0. Find the gradient of line L. First, let's rewrite the equation in the form y equals mx plus c. So we send 8y to one side of the equation, giving us 8y equals 3x plus 20. When we divide both sides of the equation by 8, this is what we get. Now that we have the equation in this form, we can straight away tell that the gradient is the coefficient of the x term, and this is 3 over 8. Find the coordinates of the point where line L cuts the y-axis. At the point where the line cuts the y-axis, the x-coordinate is 0. When we substitute x equals 0 into the equation, we get y equals 5 over 2. And so the coordinates will be 0, 5 over 2. The coordinates of P are negative 3, 8, and the coordinates of Q are 9, negative 2. Calculate the length of PQ. By applying the distance formula, the length of PQ will be the square root of negative 3 minus 9 squared plus 8 minus negative 2 squared. When we type this into the calculator, we get 15.6 rounded to 3 significant figures. Find the equation of the line parallel to PQ that passes through the point 6, negative 1. The equation of a straight line can be expressed in the form y equals mx plus c. So we need to find the values of m and c. Since this line is parallel to PQ, their gradients should be equal. The gradient of PQ is 8 minus negative 2 divided by negative 3 minus 9, which is equal to negative 5 over 6. So now that we have the gradients and we know one set of coordinates through which the line passes, we substitute these values into the equation and this is what we get. When we make C the subject, we have C equals 4. And so the equation of the line is y equals negative 5 over 6x plus 4. Find the equation of the perpendicular bisector of PQ. On the diagram, we've indicated the perpendicular bisector of PQ with a broken line. It's a straight line and so its equation can be expressed in the form y equals mx plus c. Since this line is perpendicular to PQ, the product of their gradients will be equal to negative 1. We found the gradient of PQ in the initial question as negative 5 over 6. And so we have m times negative 5 over 6 equals negative 1. When we make m the subject, we get 6 over 5. In addition to the gradients, we need to know one set of coordinates on the line to be able to find the value of C. Since the line bisects the line PQ, it means it intersects PQ at its midpoint. We've labeled the midpoint as Z. The x-coordinate of Z is -3 plus 9 divided by 2, which is equal to 3. And the y-coordinate is 8 plus -2 divided by 2, which is 3. When we substitute these values into the equation, we have 3 equals 6 over 5 times 3 plus C. When we make C the subject, we get -3 over 5. Now that we have the values of M and C, the equation of the line is y equals 6 over 5x minus 3 over 5. The diagram shows the graphs of two functions. Write down each function. This function is a straight line, which can be expressed as f of x equals mx plus c. The value of c is the point where the line crosses the y-axis, and that is 5. Since we know 2 points on the line, 0, 5 and -5, 0, we can find the gradient m of the line. This gives us m equals 0 minus 5 divided by -5 minus 0, which is equal to 1. When we substitute these values into f of x equals mx plus c, our final answer becomes f of x equals x plus 5. This function is a sine function and can be expressed as a sine x, where a is the amplitude of the sine wave. In this case, the amplitude is 2, and so our final answer is f of x equals 2 sine x. The diagram shows the graph of another function. By drawing a suitable tangent, find an estimate for the gradient of the function at the point P. First, we draw a tangent to the curve at point P. Then we pick two coordinates on this line, which we can use to estimate the gradient. One of the points is the coordinates of point P, and the other has coordinates 0.5, 0.7. Based on the gradient formula, we have m equals 2.7 minus 0.7 divided by 2 minus 0.5. When we type this into the calculator, we get the gradient as 4 over 3, which is approximately 1.33, rounded to 3 significant figures. Find g of 6. To find g of 6, we replace x with 6 in g of x. This gives us 2 times 6 divided by 6 minus 3, which is equal to 4. Find f of g of 4. First, let's find g of 4 by replacing x with 4 in g of x. This gives us 2 times 4 divided by 4 minus 3, which is equal to 8. So for f of g of 4, wherever we see x in f of x, we take it out and replace it with g of 4, which is 8. This gives us 7 times 8 minus 4, which is equal to 52. Find f of h of x. To get f of h of x, wherever we see x in f of x, we take it out and replace it with h of x, which is x squared. This gives us 7x squared minus 4. Find f of x divided by 2 plus g of x. Give your answer as a single fraction in terms of x in its simplest form. When we substitute f of x equals 7x minus 4 and g of x equals 2x over x minus 3 into the expression, this is what we get. To get the LCM, we simply multiply the denominators of both fractions. 2 goes into the LCM and we are left with x minus 3, which multiplies the numerator to give us 7x minus 4 times x minus 3. X minus 3 goes into the denominator and we are left with 2, which multiplies the numerator, giving us 2x times 2. When we expand the brackets in the numerator, this is what we get. Negative 4x plus 4x is 0, and so for our numerator, we have 7x squared minus 21x plus 12. Our final answer becomes 7x squared minus 21x plus 12 divided by 2 times x minus 3. Find the value of x when f of x plus 2 equals negative 11. To get f of x plus 2, we replace x with x plus 2 in f of x. This gives us 7 times x plus 2 minus 4 equals negative 11. When we expand the brackets, 7 times x is 7x. 7 times 2 is 14. When we group like terms, this is what we get. When we divide both sides of the equation by 7, we have x equals negative 3. Find the values of p that satisfy h of p equals p. To get h of p, we replace x in h of x with p, and this gives us p squared, which in this case is equal to p. The only values p can have to satisfy this equation are 0 and 1. 0 squared is 0 and 1 squared is 1. A curve has equation y equals 4x cubed minus 3x plus 3. Find the coordinates of the two stationary points. At any stationary point, dy dx is equal to 0. To get dy dx, we differentiate the equation of the curve, and this gives us 12x squared minus 3, which we equate to 0 to get the x coordinates of the stationary point. When we make x squared the subject of the equation, this is what we get. When we take square roots of both sides of the equation, we have x equals plus and minus square root of 0.25. This means we have two x values. The positive square root of 0.25 is 0.5. And the negative square root of 0.25 is negative 0.5. To find the corresponding y coordinates, we substitute the x values into the equation of the curve. When x equals 0.5, y is equal to 4 times 0.5 cubed minus 3 times 0.5 plus 3, which is equal to 2. When x is negative 0.5, y is equal to 4 times negative 0.5 cubed minus 3 times negative 0.5 plus 3, which is equal to 4. Determine whether each of the stationary points is a maximum or a minimum. Give reasons for your answers. The second derivative helps us determine the nature of the stationary points. To get the second derivative, we need to differentiate dy dx. dy dx is 12x squared minus 3, and when we differentiate this, we get 24x. When we substitute x equals 0.5 into the second derivative, we get 12. Since this result is positive, it means the stationary point is a minimum. When we substitute x equals negative 0.5 into the second derivative, we get negative 12. Since this result is negative, it means the stationary point is a maximum. The graph of y equals x squared minus x plus 1 is shown on the grid. By drawing a suitable line on the grid, solve the equation x squared minus 2x minus 2 equals 0. To be able to determine the straight line we need to draw on the grid, let's rearrange the equation to have the function of the quadratic on one side of the equation. We can rewrite negative 2x as negative x minus x, and we can rewrite negative 2 as 1 minus 3. When we leave x squared minus x plus 1, which is the function of the quadratic curve, and move the other terms to the other side of the equation, this is what we get. This means we need to draw the line y equals x plus 3 on the grid. After drawing the line, we need to mark the intersection points and read the x values of these points. And so our final answers are x equals negative 0.75 or x equals 2.75. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.